The mass spectroscopy is based on the positive ion generation. For its most popular model, the electron impact ionization with magnetic sector analyzer. The sample under investigation is converted into vapor phase and bombarded with electrons having energy sufficient to knock out one electron from it to produce a positively charged ion called molecular ion or parent ion, which is donated by molecular ion. Positively charged molecular ion is often unstable, and with increase in energy according to bond strength, they break into fragments called fragment or data ion, which is donated by molecular ion. Ions formed are separated in analyzer under the influence of electric and magnetic field and are recorded by the detector to give rise a mass spectrum.
Multi-TOF mass spectrometry is called mass-assisted laser desorption ionization time or flight mass spectrometry. Is a commonly used MS technique. MALDI is a soft ionization technique to create ions with minimal fragmentation by using a laser energy. In TOF, the protonated ions are accelerated by an electric field to make an ion have the same kinetic energy as any other ions that have the same energy. The velocity of the ion depends on the mass to charge ratio, and the time that takes for the ion to reach a detector is measured. Triple quadrupole mass spectrometry. The triple quadrupole mass spectrometer is a tandem mass spectrometer in which the first and third quadrupoles act as mass filters and the second act as a collection cell to fragment the selected precursor ions and to generate fragment ions. The TQMS is probably the most famous and widely used tandem MS, which is relatively simple and easy to use with good reproducibility to offer various applications at a low cost. Triple quadrupole mass spectrometer can be used for structural elucidation that can provide information about fragmentation patterns. TMPQ is very useful for quantitative studies due to increased sensitivity and specificity, yielding lower detection and quantification limits. TQMS is a vital option for many areas such as pharmaceutical development, clinical research, environmental studies, and so on. Quadrupole arbitrage mass spectrometry. In the quadrupole arbitrage mass spectrometer that combines the high performance quadrupole precursor selection with high resolution, accurate mass arbitrage detection, the first mass analyzer is a quadrupole and the second one is high resolution arbitrage. It can be widely used in various fields like proteomics, metabolomics, food safety, toxicology, and so on. Quadrupole trap mass spectrometry. The quadrupole trap MS is a hybrid triple mass spectrometer. Different from classical triple quadrupole mass spectrometry, the Q3 can work as either a standard quadrupole mass filter or a linear ion trap with higher sensitivity than traditional 3D ion trap. This instrument retains the classical triple quadrupole scan functions like selected reaction monitoring SRM, and it also can be used for sensitive ion trap experiments. Hybrid linear ion trap orbitrap mass spectrometry. The hybrid linear trap orbitrap MS that combines a linear ion trap and high resolution orbitrap is one of the tandem mass spectrometers. The lead uses a set of quadrupole rods to confine ions radially and a static electrical potential on the end electrodes to confine the ions axially. And the orbitrap consists of an axial symmetrical mass analyzer and make ions in an orbital motion around the spindle. Then the image current is detected and converted to a mass spectrum by a Fourier transform. This hybrid mass spectrometer is widely used in proteomics and metabolomics analysis.
Mass spectrometer mainly consists of 5 components. First, inlet system. Second, ion generation chamber. Third, analyzer tube. Fourth, ion collector. And fifth, data collection system. The inlet system transfers the gaseous form of sample into the vacuum of the ion generation chamber of mass spectrometer. In the ion generation chamber, neutral sample molecules are ionized and then accelerated into the mass analyzer tube. The mass analyzer tube is the most important part on which a range of the mass spectrometer depends. This segment separates generated ion either in space or in time, according to their mass to charge ratio. Once the ions are separated, they are collected and detected in ion collector chamber. Then, the signal are transferred to a data collection system for data investigation. The high vacuum is applied between the ion generation chamber, analyzer, and ion collector. The vacuum system is maintaining the low pressure which minimizes the chance of ion molecule reaction, scattering, and neutralization of the ion.